Hi everyone, and welcome. In this video, we'll dive into two critical steps of the k-means clustering algorithm, a fundamental tool in machine learning. K-means help us automatically group data points in clusters based on their similarity. These clusters are defined by their centroids, which are essentially the center point of each document classification and image compression. Today we will focus on two key functions that make keywords: finding closed centroids and computing new centroids. For the function 1 in this type, finding closed centroids, find closed centroids. Let's start with the find closest. Yes, this one. And for inputs, for x and mn and input data matrix, m represent the number of examples data points and n represent the number of features, like that, and this n and this m1. For the centroid matrix, k represent the number of clustering, therefore number of centroids. Each row represents the coordinates of the centroids. For output is this one is I'm calling in part, and for the output and m array, this array stores the centroid with each point's data is assigned. For example, idx equal to j means that each data point close the g centroids. For each data point, outer loop throughout all centroids, calculate the equation distance between data point and each centroids. To keep track the minimum distance found so far and index the corresponding centroids. Assign the data points to the closed centroid. Code example and explanation is this and this one. And for def find x, sorry, I will search, and yes, this, and yes, this findings is this, and the centroid shape is 0. Yes, it's this one, and x equal to, yes, the centroids init of centroids. And for each data point for outer loop through all some centroids and inner loop, and calculate the Euclidean distance between the data point and each centroid. The Euclidean distance is the straight line distance between 2 points. As output progress, keep track of the minimum distance found so far and the index of the corresponding centroid. Assign the data point to the closed centroid. Store the index in the idx array. Code example and explanation for the Python. The definition: find closed centroids. Yes, is this one. idx equal to find closed centroid x and centroids, and optionally plot progress. If plot progress is plot progress k means x centroids, previous centroids idx and ki, and previous centroids is centroids. And given a membership and compute new centroids for this, and we will define the new centroids equal to compute centroid x, idx and k1. If np.array equal centroids and new centroids, we will our program will print reach the optimal point. Else centroids equal to new centroids. If MP array equal to print rigid, the optimal point. After that, we will break and we will finish the program, and after that we will plat that shell and return centroid and IDX. I will explain the code line by line and emphasize the float int represent the largest possible distance initially, how MP, lineal and norm calculates the SLIN distance, and how the IDX array is updated. Show a sample example and demonstrate how the functions works. And now look at the compute centroid function, and I will say compute yes, this is our for exercise 2, and specifically for centroid we set that this one. And yes, our code block, in the code block we will define the compute centroids x, IDX and the k, returns to new centroids by computing the means of the data points assigned to each centroid. For our arguments x equal to end array and IDX the end array, m and end is a data points, m array containing index of closed centroid for each example in x of the return centroids and array key and new address computed. Our input x the m and n data matrix, IDX the m array of centroid indices, k the numbers of clusters output. Our output centroids the k and n matrix of the new centroid position. How the function works: for each cluster, select all data points assigned to that cluster and calculate the mean average of these data points. Set this mean and new position at centroid for the cluster. Code example and explanation is this. We have the useful variables m and n equal to x point shape, and we need to return the following variables correctly. And our centroids equal to n point zeros k and n. For I'm starting the coding here. For k in range points in cluster is the select point assigned to cluster k I set, and I said if the point in cluster size bigger than 0, and in this part I checked the cluster is empty or not empty, and our centroids k equal to mp dot mean points in cluster and axis equal to 0. In this part I calculated the mean of the points in cluster guide. And now check our implementation by running the cell below, and the k-means on the sample set is this one, and I don't need to implement anything for this by sample running code program below, and I will in the Python x amp array 1 to yes, in this part I will set the initial centroids, and the number of each iteration is max iteration equal to 10, and in run key means centroids IDX in the run key means and x intel centroids and through part and the random initialization. The initialization assignment of centroid of the example dataset by the figure 1. In practice, good strategy initializing centroid select random example in training set. And note, I will do not implement anything. So in this part only I said, and I'm coding the part, but I do need implement anything. So I can run the commands against bit, this time random initial centroid, run the cell below several times and observe how different clusters created based on the initial points chosen, and set the number centroid as max number iteration and k equals to 0 and max iteration is 10. And image comparison is this part and our dataset. So in this video I have explored two key functions in key means: find closest centroids and compute centroids. These functions work together in Iteratively, the first assigned data points close the centroids and the second updates the centroid pointers. And this process repeats until the centroids no longer move significantly, resulting in clustering data. In a future video, we would like to complete the key-means algorithm and its implementation in Python. Thanks for watching.